Welcome, everyone. We'll be waiting 2 to 3 minutes to get started as a courtesy to those who are still in the middle of connecting. Welcome, everyone. Thanks for joining us and thanks for being part of our community. We have a great topic to cover today, but first, a few reminders. Please feel free to ask questions at any time by typing them in the IM window. Be aware that any questions you post will be publicly visible. However, if you prefer, you can ask any of your questions anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time, but I want to provide an additional mechanism to ensure any questions we miss might miss get answered. If you'll visit aka.ms/Azure Sentinel Community, you'll be able to ask questions on our Azure Sentinel forum. If you're listening to this after the fact as a recording, that's also a great place to ask. And any of these links I'm referencing here are pasted in the IM window, so take a look at that. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/Azure Sentinel Recordings. While you're there, please join our community by visiting aka.ms/security community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, requesting features, giving feedback, reviewing our product roadmaps, attending in-person events, or joining webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. We have a great topic for you today. We'll be talking about threat hunting with Azure Sentinel. I'd like to introduce you to our presenters today, Raz Hertzberg, Shane Ray, and Pete Bryant. They're all members of the Azure Sentinel product team, so they have deep expertise in this topic. Without further ado, I will turn it over to them. Raz?
Thanks, Ryan. Hi, everybody. Thank you for joining us. What I'm going to start with is a short overview of Azure Sentinel. I think the best way to get a real overview is using a live demo, so that's what we're going to do today. What you see here is Azure Sentinel Live. Azure Sentinel is today still in preview, but it will be GA'd next week. So we are very, very close to reaching the GA point. And I'm going to start from an overview. So Azure Sentinel is a cloud-native SIEM. When we say cloud-native, we mean cloud-native. This is a SIEM as a service. So a SIEM being the place that you aggregate all of your security logs, all of your security appliances. There's a lot of maintenance to traditional on-prem SIEMs. And they also tend to be a little bit unsuitable to the modern cloud environment. Most organizations don't want to take data down from the cloud on-prem, which is why a cloud-native SIEMs make so much sense for a lot of modern organizations and modern workplaces. So without further ado, let's start going over some of the central features in Azure Sentinel. I only have 15 minutes, so we won't be going through every feature, but you will be getting kind of a good overview of the main features and of the main use cases. What we see here is the Azure Sentinel overview dashboard, but I want to kind of walk through a regular usage flow. So the first thing you do with any SIEM product would be connecting your data sources. Although Azure Sentinel is an Azure native product, a Microsoft native product, we are a full-fledged SIEM, meaning we support your on-prem data environments. We support multi-cloud. You can see our AWS connector here. We support different network appliances from working with third-party vendors. We really, really care about being a complete SIEM solution for your security operations center. That being said, there are still a lot of advantages to being native Azure. For example, connecting any Microsoft native data source is really done by just a click of a button. For example, if I look at my Azure Active Directory connector and I open my connectors page, I can see that connecting Azure Active Directory would be done by just clicking on this one button, and the logs would automatically start flowing into Sentinel. We also support all of the on-prem connectors. We have a generic syslog connector, a generic Ceph connector, and onboarding data to Azure Sentinel is really, really fast. And now once you onboard data into Azure Sentinel, we really want to give an easy onboarding experience in terms of what to do with the data source you have now enabled. One really good example of that is our built-in workbooks. Workbooks are basically smart dashboards. We provide built-in dashboards on top of the data sources you can connect to Azure Sentinel. And each and every one of those dashboards was built with a lot of consideration for what are the most interesting security questions you could ask on top of the data sources you have just brought into Azure Sentinel. So, for example, let's look at my Palo Alto dashboard. So in this example, once you have connected your Palo Alto logs here, you could start using this built-in dashboard, which we have built together with Palo Alto to provide the most interesting data points on top of your Palo Alto data. So let's give it a second to load here. This is running a lot of queries in the backend, but you can see that now we have our built-in dashboard filled with a lot of useful information. And the cool thing about our dashboards are they can really be used for a very powerful interactive platform. For example, if I click on looking at just malicious threats here, the entire dashboard can be filtered according to my selection. If I continue looking a little bit down, I can see that I can search for specific things. Oops, not in Hebrew, but in English, I can search for specific threats and view relevant information. Every single dashboard is basically built from a set of queries that you can then modify, tweak around, create your own dashboards, combine a few different dashboards. So this is a very, very powerful platform for viewing your data and for learning about the new data source you have just connected into Sentinel. Another thing you can do with Azure Sentinel right out of the box is start using a large set of analytic rules we provide out of the box. We provide over 100 different analytic rules that you can use to detect threats in your environment. All of the rules you see here are pre-built into Sentinel for your SOC to just click on enable once they have the required data source. All of those rules were written by our own threat hunters team, which is Shane and Ajit and the guys you will hear from later in this session. And each one of those detections was carefully formulated. It was tested against different data types and data sources to make sure that it's not noisy, that it's a relevant detection to enable in your environment. And there's a lot to learn from this set of built-in detections. Those were written using the expertise of Microsoft's own best threat hunters. And now, for example, let's say that I want to enable a detection in my environment. I can choose a relevant detection. And I can click on create rule to create the rule in my environment. Let me zoom in a bit so it's better. Here we go. So now I can see that I can start creating my own logic out of this built-in detection. Here I can see all of the details are pre-filled in according to this built-in detection. They are also tagged based on meter tactics. And I can also play around with the rule. I can modify the logic. And I can also select automated workflows, automated logic of playbooks, which are basically an automated set of work items to be automatically triggered. This is our sort tool, and you can select a specific playbook to run once this alert is triggered. I will go into a little bit more details on what this means in just a second.
I'm sorry to interrupt. Would you mind? We're getting several requests just to zoom in a little bit, or maybe increase the zoom on the browser. People are having a little bit of trouble.
Yeah. Sorry, I'm on a huge screen, so it's my fault.
Thank you. Sorry for interrupting.
Sure, no worries. Wait, maybe that's a little bit too much. Hang on. Okay, I think that should be better, but let me know if it isn't. Thanks, Ryan. And once you're done, you can review all of the logic you have selected and choose to create your rule. When I go back to the Analytics tab, I can see all of the active rules I have running in my environment, and I can of course disable them, modify them, delete them, etc. Now, once I have a rule triggered in Azure Sentinel, I can start investigating it to try and understand what happened. Every rule, once it opens, will open an incident in Azure Sentinel, and incidents can be investigated in a number of different ways. You can, first of all, always go into the raw logs and look at the actual events that triggered the original alert. So for example, here I clicked on looking at the original events that triggered the alert, and I can see that this was the raw event that triggered my alert. I can continue writing queries and asking questions on top of my data, or I can also use what we call the graph investigation tool. The graph investigation tool is a tool that aims to kind of help you, helps you to investigate your alerts faster and to gain better context of what happened in the face of an attack, and to make sure you discover the full scope of breach. The way this tool works is it starts from the alert. Let me go back a few steps here because I already worked on this investigation. So let me just go back here. This would be how this would start. I entered an alert, and I can see the entities directly related to this alert. Let me also zoom in here. But now I can start asking questions on top of my raw data to make me understand a little bit more about what happened in this alert. So for example, I could look at this host, and I can ask if there are any other related alerts. By clicking on this, this will run the query in the background and return any relevant alerts that are related to this specific host. I can also ask questions that are more kind of like hunting questions, right? For example, I can ask what are the processes that ran on the host in the time frame of this alert. This will, again, run on top of all of the data you have in Azure Sentinel and bring back the results here. I can continue expanding my alert this way, and I can learn about a lot of different related things I have on top of my data. This makes me able to investigate faster, and it also enables analysts that are not proficient with writing their own queries about what it is I want to ask and what it is I want to learn from on this alert. I can also always pivot to the raw events view to view the actual events that triggered those entities. looking at the timeline, I can now really get a better understanding of what happened and how this suits my incident's time frame. I can also search for specific entities and learn more about each entity by clicking on it and viewing all of the details I have on that entity in my system. The last thing I want to show you is our SOAR platform. So Azure Sentinel comes pre-built with a SOAR platform, which is based on another Azure product called Logic Apps. Logic Apps allows you to build automated workflows in a very simple and UI-friendly way. What I'm going to do is show you this workflow and explain how you can use that to automate responses in your SOC. Let's give it a second. I'm sorry, let's try again. That's my network though. Okay. Yeah, a lot of notebooks. So looking at an example here. Hang on. Okay, let's try this one. So hang on. Sorry for this glitch. Here we go. So looking at this automated workflow, I can see that I have a trigger that starts from an Azure Sentinel alert. What this playbook will then do is open an incident in ServiceNow with my alerts details in it. And then it will also post a message to my SOC channel, and it will send an approval email. What happens here is that you have a built-in trigger from an Azure Sentinel alert, and you can then use all of the different fields you have in that alert, really simply using a UI in order to fill out different templates and different response steps to happen automatically. For example, in this alert, we have an IP, and we want to send an email asking our IT operations guy whether he wants to block this user and IP or if he wants to block the alert. So we will send an email that states the severity of the alert using the dynamic alert severity field, the name of the alert using the dynamic alert name, and the description of the alert. You can see that all of the fields I have available in my alert can be easily used as part of this response. The next thing this playbook will actually do is evaluate a condition. That condition is based on 2 buttons that will appear in this email. You see the user options are block IP and ignore. And then this playbook will evaluate whether the user has clicked on block IP or ignore and operate accordingly. If the user clicked on ignore, this will just close my incident in ServiceNow. And if the user clicks on block IP, this will go ahead and block the IP in Azure Active Directory or block the IP in my Palo Alto firewall. This is a very, very powerful tool. And it also enables you to really, really automate. I just zoomed out a bit so you see the whole workflow. But this also really enables you to build automated workflows to make your SOC work faster. Logic App playbooks can be easily recursively chained to one another. And they also have very, very powerful operations, such as a connector for running an Azure function, which enables you to do basically anything with your alerts and your data. And if you remember before, I showed you that when I defined an alert in Azure Sentinel, I could select the playbook to run automatically every time that alert is triggered. So this is a very powerful way to use Sentinel and to automate workflows in your SOC. So this was everything from me. We got kind of like a good, fast overview of different functionalities in Sentinel. So thank you for listening, and I'm going to move to Shane, who will continue to talk about threat hunting in Azure Sentinel.
Great, thanks, Radis. Yeah, so I'm Shane Ray. I'm going to go ahead and get my presentation up here. Give me just a second. Hold on. And okay, hopefully everybody can see that. And so You know, as Raz is, I'm on the Azure Sentinel team, and I'm one of the threat hunters. And additionally, I am a detection and hunting query author that contributes to the GitHub project out there. So you probably see my name out there. What I'm going to cover today is just kind of a quick overview of ways to identify threat hunting opportunities in your data. We do this internally across multiple data sets from internal sets, and then we also do partner with customers and gain access to their data and help them hunt through their data in order to improve our detections or our hunting queries for the overall GitHub experience. A couple of just key principles that I'll cover in here. When we're threat hunting, there's generally several starting points. A lot of times they're related to things that are provided to you, right? And there's also ones that you identify yourselves, right? Additionally, you got to learn the data. You got to learn your own data, and obviously over time you learn more and more about the data. What's cool about my job is I get to work with all different types of data types on different customers. And so it's always a new learning, right? Because you got to learn that data over again. And then, how you pivot off of that while you're hunting to then decide, okay, I'm going to go build a query out of this and make an alert, or I'm going to put it in my my hunting query backlog, and I'm going to go run it every once in a while and maybe improve it over time and create an alert for it. We basically want to learn on our own data. Build the queries from that, right? And so we can identify these interesting hunting opportunities to pivot on later. So a couple of things, like we're talking about starting points. Generally, we identify things through security blogs, right? Or through security tools that, do some type of attack like PowerShell Empire, right? We learn about industry attacks, right? Some denial of service hits, in this case, energy companies, right? Or we have good old alerts. And obviously there's many other things in between that. And, I think that this is a great starting point, and this is, where people need to focus. But in addition, you got to understand kind of your own data, and you got to identify your own ways to hunt in your own environment, because some of these may not apply to you, and there may be activity happening in your environment that you need to be aware of that may not be bubbled up in some of these other places. So identify your own, right? So let's talk about that. Leverage your practical knowledge, right? So your practical knowledge is what you know about your environment, what you know about previous security issues in your environment, all those types of things. I got all these assets. These are the most important accounts in our environment, right? There's things that you can use to identify things in your environment, right? So data types and entities. We talked about what data types do you have, right? I've got security event logs, but I've also got AWS logs, and I've got Azure activity logs and what have you. And what types of entities are in those? You need to know those, because if you don't, then you don't know how to really pivot through the data, right? What you really want to do then is basically bring that information together. And in order to bring it together, we do internally, we build kind of a matrix of what we can pivot across, right? And that matrix kind of looks like this, right? This is an example. And this is something that I think that we kind of bring through into Azure Sentinel, not in this type of view. We do show you your data types that you have. We don't necessarily bring it across to the entity side mapping like this, but this is something that we're looking at, trying to put into like the GitHub as in the wiki to kind of help people going forward, so they don't have to build these on their own and go through the process. And just some clarity on this: the red basically means it's not available in that data type. The yellow means it's available, but not always, depending on the type of event coming through. And the green means generally it's always available. So you can kind of see how we would, maybe pivot through things. In this case, IP address looks like a good one, or maybe a host or account, right? So that's basically identifying your environment, understanding what you really can do with your data. And then once you understand this, you can actually move forward onto it, right? So let's talk about just data learning real quick. So you've got a bunch of data, right? You kind of want to ask yourself some questions. They're fairly simple concepts, but they're related to your interesting entities, right? So for example, you want to say what's anomalous for my environment. I should never see an inbound connection via public IP address connecting to my internal web server, right? That would be an anomaly, right? You probably would be very unexpected to see that. You shouldn't see it. You should have protections in place where it didn't happen. But again, that's an anomaly. You know, what's rare? Example, it would be rare for an account type. Say you have a VIP account to access this system type except at a given time, or let's say you have a service that does patching and there's an account associated with that, right? You should rarely ever see it access except for during patching time or what have you. So you kind of know that you know these accounts, but it's rare that they run, and it's rare that they would be used in certain contexts, right? So you understand that. Then we go on to like what's common, right? So really, this is how can I identify what is common without knowing what it is, right? And that's where you can use the power of the log analytics behind Azure Sentinel to identify and understand, oh, these are common for my environment. And I'll walk through that a little bit as I move forward here. And then what's expected. So these are things you can just exclude. You could say, oh, well, I know that this process always runs across all my systems because it's whatever, it's SCCM or something, right? And so I want to do that. Or I always know that this admin is adding mailboxes to Office activity, and so I know that this is normal. And I expect them to be the one adding mailboxes, right? Or maybe forwarding rules or things like that. And then you basically can combine these concepts together in like kind of one query to basically easily identify hunting opportunities. Oh, you want to identify something interesting, and then we're going to go pivot off of that. So I'll give you an example. So the way that we normally identify things is like, I got an alert, let me go pivot on it and figure out what's going on here, or I read this blog or what have you. Well, in this case, I actually just happened to be chatting with a friend about entropy, and it wasn't me chatting, he was chatting with me about it because I'm not a physics guy and I don't deal with entropy on a daily, regular basis, right? So we were just talking, and I was thinking, well, can we use this, right? Can we use this in rare process discovery, for example, or other rare things? I just chose process discovery. We have a lot of data around processes, so it's kind of the easiest to walk through. What I did is I'm like, okay, well, I don't know enough about it. Let me go read about it. And so I ran across this Shannon entropy blog, and I read it, and this guy did excuse me, I have a bit of a cold. This guy did a great write-up on this. So I just read it, and it was easy to kind of follow and understand what was going on. I'm like, well, let's try to do this. So I wrote a query, right, and I built it, and now it's up available in our GitHub, and it's actually quite useful, especially for hunting. It helps you pivot through the data rather readily and identify items that you're really interested in. The main piece of this is just a simple calculation. The one that says extend process entropy there, that's just a log calculation. You have to generate the values there, and I'm going to walk through that. And then we also added a weight, and I'll kind of talk about what the weight is. But you can see here that this was nothing security specific. I just took a concept and said, hey, let's apply it and see what value it gives us, right? So let me go ahead and break down the query. We want to we talked about what's common and what's expected. We really want to remove those, and we really don't want that information present. So what we do is we go in and we kind of understand the data. Okay, over the last 7 days, what have I seen for process creation events? And and we look at these counts and we see these giant counts. Like, okay, well, I know conhost runs all over the place, right? I know this about my environment. Obviously, all Windows, this runs on. So what I want to do is I want to say, okay, well, conhost I'm just going to exclude by default. I don't even need to have it, calculate that, all right? So the next step is, all right, let me take a look at the counts that are, basically less than 100,000. In this case, I just chose 100,000. Or sorry, greater than 100,000, because I want to only include less than 100,000. So what I do here is I identify this is the group that I want to exclude. And so I say, okay, these are the things I want to exclude. These are over 100,000. I don't want to use those in my entry calculation because it'll skew the results, right? So then I move forward even further and I say, okay, well, let me go ahead and include, let me remove conhost here, like I talked about, right? I'm going to gather all my security events across that data. I'm going to basically build a picture based on a host and a process. Those are my two pieces. The buckets are the computers in Entropy, and the process is really the classes, right? So kind of going through the process, I kind of run this and I say, okay, well, here's really what I want to see. I want to take a look at all my security events. I want to exclude the ones that are over 100,000 across my environment, and then I want to see, what else is there. All right, and so this kind of gives me a list of things, and some of these are common, right? But common meaning well known. They may not be common for an environment, but they might be further interesting items. But this is, again, just the initial list. I'm not really using this. So then I step forward and I add in my other, after I see what's there, I add in my other items that I want to make sure are excluded, right? So I'm like, okay, I don't want to include any of these others that I know for sure are legit, but they're not reaching 100,000. Okay, great. So now I've kind of reduced the set again. And now we go into the larger query where we actually do the entropy calculation. So we've gotten rid of the common and the expected, right? Now we want to look for the rare and the anomalous, right? So with entropy in this specific scenario, we're just going to go build like counts, different types of counts to use as denominators and numerators in the calculation. You could see in the calculation that I was doing some division and multiplication based on logs. And so what we do here effectively is we're saying, let me understand what the prevalence is for a given process in my environment. So I'm taking the whole environment and I'm understanding prevalence there. So that allows me to kind of immediately identify some weight factors there that go into the the entropy calculation. So then next I move on. Okay, I need to look at each of the processes, right, per host effectively, right? And that allows me to understand, okay, here's going to be my counts for a given process on a computer. And then I have that, and then I also have just overall counts for processes in my environment. So I've got the pieces that I need to move forward with the actual entropy calculation, which is a simple log2 calculation, which is, this is, I talked with a guy about a real math wizard about what this is really doing. And just logarithmic just allows you to see the it makes the values jump out at a higher level for you to see more easily. So in this case, what happened when I did this is I got some good information, but it wasn't necessarily weighted properly. So I added in a weight, and I took things, the lower the weight, the more interesting it is. So I basically took the counts for that for each host, and then distinct computers with that count, and then basically made them a real number and multiplied it by the entropy number. So and then after that, I basically, as I was looking at the data, it made the most sense that things lower than 100 for my environment really needed the review, not the things over 100. And that was, again, I looked at the data, and because I know my data and I'm seeing these processes show up, all right, it looked like anything lower than 100 made sense. And then we simply just join it back on the data so we can build out context, right? You can see here, I'm building out, all right, this was the subject user ID, these were the process paths, here's the parent process, all that type of stuff, to build out a better picture for what I might be interested in pivoting on, because I need to know these other things to be able to pivot on. I need to know the account, right? But that way I can pivot into other data sets. So let's go into pivoting, right? We're talking about how do we use that. So we got some results set out of that. It's I'm going to go kind of I'm going to go through that pretty quickly. I don't have much time here. So now that I understand my data, what's next? Okay, I'm going to pivot. So I'm going to use my matrix, and I'm going to understand what else I can pivot into based on common entities that are in the result set that I have. You already kind of know what logs are interesting in your environment, or might be most interesting based on the entities you're looking at, right? So those would be the ones you probably want to start with. Now we go and we pivot so we can provide further context. We can build an attack sequence or a story about what happened, and then we can even in log analytics you can view it as a graph to kind of even see the deltas from norm. You can build those in specifically with some rendering that you can do right in log analytics, or as Raz showed, which I'm not going to go into, the investigation graph, which is awesome, but you would need to create an alert rule for that first. And so you can kind of see here one of the time series analysis items that we did. You can clearly see the deltas right above and below, and those are interesting data points, and those are things we would investigate. And if I was to hover over this, if it was live, it would show you what the data point really was, and you could then say, okay, well, I want to pivot on whatever that machine was or IP was that was sending all of this data in this case, right? So let's kind of put this in to like an actual sequence, and I'll just start with the process entropy item that I built. And so this is an example of walking through. I ran it on a data set. This has been anonymized, as you can probably tell. But you can easily see here, all right, well, here's my process entropy, right? And I can see my weights, and it's, the lower basically means the more rare or more anomalous it is. And you can see all these processes that are running. It's pretty clear that there's something going on here. But more interesting is, if we look over here, we notice we see some encoding stuff, right? And encoding is always an interesting potential investigation avenue. We see a lot of encoding, base64 encoding happening on PowerShell, but we also see that it's like normal. So we would have to, all right, we want to know, is this normal for my environment? Let me dig in further. I see I've got, here's the base64 encoding. It was PS test. Somebody was running something interesting. So how do I pivot on that data from here? Now that I've done this hunting and I've got this item I'm interested in, what do I do? Well, let's use the other stuff that we have already. So we've got other process related queries in there. This is a hunting query that's currently in there, right? So I go run it. I can run this query, right? But I can also modify the query, which will bring you directly back into log analytics. If you do the modification, you do the view results here, you can go into log analytics directly. And what I've done is I basically modified the query so that I could decode the string automatically as part of the query. And so you can see here, now I've gotten something that's interesting. We've got somebody that's downloading sysinternals. They've renamed it. They're going through and running it, and they're doing some kind of COM object shell application to execute, right? So I can see, okay, this is interesting for me, and I've got user information. I've got this account name and the domain. I've got the process name that was running it, and I've got time, date timestamps and computer names and stuff like that. And if I had more time, we could talk about pivoting through that. But those are things that you can continue to pivot on, either through other hunting queries or through building your own, right? And so just in summary, your mission, our mission, there's always some new attack technique, right? Go discover it, create a detection for it or hunting query for it. We prefer that you share the query. We prefer that you improve the experience for the community, share your experience, share your knowledge. And then what happens is once it gets up into the GitHub, we'll evaluate it, and when we think it's ready from the perspective of usage and feedback and what type of signal to noise ratio we see on a bunch of different data sets that we'll test against, it'll get promoted into the product directly. So, I mean, you will provide a lot of value to us if you do the same process and start adding to what we have in our GitHub. So, famous Dr. Seuss thing, right? It's kind of about you and your knowledge. Just think about something interesting and think about a way to go through it. And I'm going to go ahead and hand it off to Pete here. Pete will go ahead and cover some interesting topics related to Azure Sentinel and Azure Notebooks. Thanks, guys.
Thank you, Shane.
Thanks, Shane. So what I'm going to talk about kind of leads very nicely on from what Shane was talking about there. So one of the key things to understand as a threat hunter or a security analyst is the context around what you're seeing. You can find processes, you can find user accounts, you can find various kind of elements within your hunting that are interesting or anomalous or stand out. But unless you can understand the context which that event occurs or that item happens, it can sometimes be hard to kind of work out whether something is just anomalous, whether it is malicious, or whether it's just part of the day-to-day activity in your enterprise. So what I'm going to show you is how we can use Azure Sentinel's integration with Azure Notebooks to provide an environment where you can bring in this context and analyst to better understand what is happening and why it's happening. So let's start. What are Azure Notebooks? Well, they're a browser-based code execution environment. They allow you to combine text with code and the output of that code within a single browser interface. And they're integrated directly into Azure Sentinel. You can also do various things with them, including present. What you're seeing here on my screen is actually the Azure Notebooks interface. It has a presentation or a slideshow view, which is what I'm using here. And you'll see as we go through, I've combined text and images with code snippets, which we can run in real time as we go through. One of the other things I'm going to not cover here, but kind of touch upon as we go through is Mystic Pi. So Mystic Pi is a package of tools to help threat hunters and analysts use these notebooks to interact with security data in Sentinel and other tools. So collect that data, modify it, manipulate it, and deploy it. So definitely worth checking out if you're using notebooks, looking to use notebooks, or just using Python for security analytics in general. So one of the first things you're going to want to do with notebooks is connect them to Azure Sentinel. So whilst notebooks are integrated with Sentinel, you still need to connect to your workspace and collect the data. So in this case, we're going to want to connect to Sentinel in order to collect our starting point of the investigation, which could be the output of an alert or the output of a hunt that we've done. So using Azure Sentinel to collect this data and using the Mystic Pi package, we can very easily and quickly do this. So whilst it's a coding environment, you don't have to be an expert programmer to make use of any of this. With Mystic Pi, you can write 3 lines of code and create a connection to Azure Sentinel to be able to query the data, which is, again, really cool and really quick and easy, and makes what is a very powerful capability in notebooks really accessible to any level of analyst. So taking a hunting bookmark, so this is the output of our threat hunt we found interesting, and using it as a starting point for our deeper investigation when we need a bit of context. So here we found a SSH login from one of our Linux hosts that we want to go investigate in a bit more detail. Now, as a threat hunter, what do I know about this event? Well, initially, not a lot. I've got a host name, I've got a username, I've got an IP address. I can tell that, okay, I've got an external IP connecting on an admin port into one of my hosts. That probably isn't great, but again, in a cloud world, that's not unheard of, might not be too abnormal. In fact, that public IP could be part of my cloud infrastructure that I have whitelisted to allow. So how do I kind of work out whether this is something that I need to flag up as malicious or as normal pattern of behavior? So to use these elements in the rest of my investigation, I want to set some variables. And again, here is where I've transitioned to using some of the code rather than just text. So here I'm interactively setting these variables with the elements in that log. Now, what I want to understand first of all is, who is this user? I've got a username, but who are they? What do they do? Where do they sit? Now, one of the great features of Microsoft Cloud is this Graph API, which allows you to integrate and interact with pretty much every element of the cloud, everything from kind of sending emails to uploading SharePoint files. Now, what I'm going to use it for here is to connect to, again, very simple bit of code to get my query connection. And I'm going to query this user's details from Azure AD, so I can find out a bit more about who they are. So Again, running this code interactively, I'm querying the API, pull back the data in a nice formatted table. And I can say, actually, this user's a infrastructure admin. Them logging on is probably not too suspicious. The other great thing about these notebooks is because they're interactive, I can modify them. So as an analyst, maybe I want to see this user's phone number, so I can call them up and ask them what's going on. Quickly modify the code, bring back a different set of data, present it in a different way. Or maybe I'm an analyst that's not very good with names, and I'm much better with faces. Well, I can go get their picture off Azure AD as well. All of this has instantly given me a lot more context about what's going on. I haven't had to ingest this AD data into Sentinel. I can just query it separately via the notebook. I can also do some cool things with visualizations. So as you saw from what Raz and Shane presented, there's some great graphs and charts in Azure Sentinel, but maybe you want to do something a bit different. So here I've just plotted a timeline of this user's logins. I can see that actually the green ones are failed, the blue ones are successful. Here I've got actually a whole set of failed ones. I can drill into these a bit more and see actually I've got a whole series of failed logins followed by successful. Again, this gives me a pattern that's a bit more suspicious, gives me a bit more context that maybe I might not have spotted within just the text logs where I've just got a whole bunch of timestamps. And again, Notebooks gives me the flexibility to develop these interactive visualizations in any way I want. I can change the colors, I can change the format, I can change the size, I can do anything. You're not kind of constrained by what the tool provides you with. And also, similarly, I can do things like query the host. So I can use things like the heartbeat data from the OMS agent that's collecting data, and tools like Service Map to get a bit more context about the host. So here again, I'm just querying, in this case, Azure Sentinel to get this data back. Running a query using the KQL format and presenting it back in this graphical representation. So here I know it's an Ubuntu host, I know what OS version it's running, I know where it's based, I know what resource group it's in. Again, I've suddenly got a lot more context than I had when I just had, here's my host name, Contoso host 2. Similarly, it's not limited to connecting to Microsoft data to get this contextual information. So most organizations have a ticketing system for managing infrastructure operations, that sort of everyday work. Now I can query that to get some information about this host. Is there work expected to be going on there? Is this user Terry expected to be logging into this host at this time? Is there a known vulnerability that's waiting to be patched on that host? A whole number of things. So here, using exactly the same methods and techniques, I can connect to ServiceNow and pull back some information about the host and any tickets open for it. And I can see here, yes, I've got a ticket open for this host. It requires some patching, and actually it's listed as Terry to complete. So again, I suddenly understand that, okay, Terry probably is meant to be logging into this host. It's not too abnormal for him. He's the right role. He's got a ticket open to do it. Yes, there's some unusual log-on patterns that I saw in that timeline, but I'm not too concerned about it. Again, I've done this with multiple data sources, which I haven't had to onboard into Sentinel, but by using the really easy and quick connections of notebooks and the flexibility of Python in this case, I can query that code as I need it, query that data as I need it, sorry, and use it to provide this context. The other thing about this is, excuse me, is we don't have to create this on the fly each time. These notebooks can be saved and shared. So something like this, where I'm checking, is this IP one that we own? Is it in a private IP address range? Do we have any data about it in our flow logs that might indicate we own it? Well, I've created this logic, but I can just run this every time. All I need to do is just pass it a different IP address and it will give me a different output. So you could create a notebook for a standard investigation flow or hunt flow, give this to a more junior analyst and say, hey, all you need to do is run this notebook, just run through, enter the element you're looking for, or select the log you're looking for at the start of it, and just follow the trail of it. It's really simple and easy. As you can see here, all I'm doing is selecting it and running a cell, and it's giving me a usable output. As I said before, you can also do some really cool visualizations. So here we're looking at where this IP address is. And as we can see, it's in Seattle. Now, again, in our investigation here, that's a little bit abnormal because whilst I'm currently based in Seattle, our user was meant to be based in the United Kingdom. So I could take this further, maybe by plotting all the logons for this user over the last month to see whether actually they've traveled to the US and there are other logins here, or whether this is kind of a one-off anomaly. But again, the flexibility of notebooks means that I get to choose what I want to see, how I want to see it. The other thing you can do is also connect into threat intelligence. Now, while Sentinel has its own threat intelligence collectors and connectors, so you can bring in this data, you might not want to do that for every single source. Threat intelligence can often be a very large data set that ingesting into a centralized system might not always be the most effective thing to do. A good example of this is VirusTotal, great data repository for threat intelligence and looking things up. But you don't want to try and download all that data and ingest it each day. Instead, you want to use their API. And again, this is what we're doing here. And again, using very simple little bit of code, we can look this IP up in VT and see, actually, we've got a hit here. We've got the raw data to back up what's going on here. So again, whilst we initially saw something that looked a little bit benign, that user login on, we're starting to get a bit more context here. Strange IP location, it's in threat intelligence. We can even pull back just raw data files and look in them. So here I'm just pulling down a CSV file from the web with a list of Tor exit nodes and checking whether my IP is in it. Again, it is. And again, this is an example of a great code snippet that you can just use over and over again. Just copy and paste out of this notebook using another one, perhaps. And again, notebooks are a great way of kind of pulling together all the information from multiple data sources as part of your investigation. So you might have the output, the hunt that you've done in Sentinel. You can bring it into the notebook. You can enrich it with all this data from a whole bunch of data sources. So here I've queried Sentinel, ServiceNow, Graph API, VirusTotal, other web threat intelligence, put it all into one place. Make it very easy to review, particularly as an analyst or a threat hunter. If I'm handing this off to another analyst, maybe on a shift pattern, or for them to validate, having this all in one place is a really nice, easy way of making it understandable and repeatable. Similarly, I can do some nice things putting it all together. I'm not constrained by having it in a table. I can also map it out in this lovely graph where I've got all the different elements I'm looking at. The ServiceNow instance, the location, the threat intelligence lookups, everything. It gives me a really cool and much more kind of visual and flexible way of understanding what has happened here and whether that initially kind of benign or at least not a standout log event has suddenly got a whole much bigger context behind it that allows us to better understand whether I should go do something about it or not. So the key is here, logs are great, data is great, but really context is king in this situation. And notebooks give you a great place that's really flexible way of bringing together that raw data with that context. And there's plenty of tools out there to support it. So if you check out Mystic Pi and also the stuff we've done on the Azure Sentinel GitHub that Shane talked about earlier, there's some pre-built notebooks in there. And also, if you look at our Azure Sentinel blog, there's some great blog posts on there about using notebooks for threat hunting in a little bit more detail. So thank you very much. And we are now going to go and do a bit more Q&A and dive into some of the questions you've been asking during this webinar.
Great, thank you for that, Pete. One of the questions we've got here is, how do you recommend organizing the notebooks when you have multiple users might be coming back to find various queries?
Yeah, so the way we've organized it on the GitHub is kind of how we think about these things, but we also understand there's various ways that you might want to organize your own inside of the Azure Sentinel UX. And so the one thing to be aware of is that, you know, what we prefer is that if possible, you include your query, whatever you've defined as a detection or a hunting query, you give that and provide that to the community through the GitHub, and then it's automatically picked up once it's effectively approved. It's automatically picked up into the product, and then you're sharing your experience with every other Azure Sentinel user, and they can add what they want to it. If you're specifically talking about inside of the UX, like how you organize, I mean, you can do various. I think Chris already answered this, but you can use functions. You can do things like that to query across different tenants and stuff like that. But organization, I think, is just up to the person, how their mindset is, right? If you want to organize by entity type, meaning a processor IP type queries, or you want to do based on data type, or maybe investigation type, or that type of thing.
Great, thank you.
Mm-hmm.
Can you speak to integration with other Microsoft products a bit, especially M365?
Raz, you want to handle that?
Sure. So Azure Sentinel, in Azure Sentinel, you can collect Office activity data from two sources at the moment, Exchange and SharePoint. We'll be working on extending that. But you can collect those data types into Azure Sentinel. Storing those data types is free in Azure Sentinel, and there are, of course, built-in dashboards and rules on top of that data.
Okay, great, thank you. Also, can you explain a little bit about how Azure Sentinel differs from Azure Security Center?
Sure. So Azure Sentinel is a SIEM product. It's a place to aggregate a lot of different security providers, alerts, all of your raw data in order to enable deep investigation, and also to enable your SOC to triage and investigate cases and automate responses. It's a SIEM tool. Azure Security Center is an alert provider, similarly to how Sentinel integrates with MCAS, with Azure ATP, with other Microsoft alert providers. We support connecting Azure Security Center to Sentinel in order to investigate and triage your alerts in Azure Sentinel. Azure Security Center is not a SIEM product. It's a cloud workload protection product.
Great, thank you. I've got a question here for MISP/MindMeld integration. Is there charges for the data collected by the TI connector?
In general, yes. Every data connected into Azure Sentinel, other than Office data, which is free, is charged.
Okay, great, thank you. We're about out of time here, so I want to just give folks a few more links in case they missed them at the beginning. If we did not get to your question, you can post it here on our community at aka.ms/Azure Sentinel community. If you're looking for the recordings, they will be up there today at this link, which is aka.ms/Azure Sentinel recordings. To join our general security community, which includes all our other security products like Azure Security Center and Azure Advanced Threat Protection, all those types of ones, you can go to aka.ms/security community. And as always, we would love to hear your feedback on this webinar, what's useful, what we can do to improve. You can give us that feedback on a survey at aka.ms/Azure Sentinel webinar feedback. I want to thank everyone today, all the folks from our team who've been answering questions online. Our presenters, of course, Raz and Shane and Pete. And most of all, I want to thank all of you for joining us and being part of our community. We hope to see you on the next webinar. Thank you.